Number 6 in your study guide wants you to find all zeros, and we're going to go ahead and pretend like we don't have a graphing calculator just because it's the worst case scenario. What would you do if you didn't have that? So the first thing we would look for is seeing if we could actually factor this, but if you tried to factor this by grouping, it's not going to work out. So instead, we're going to list out the possible rational zeros. So we're going to do the P over Q. Well, think about what all of these are. The Q comes from your leading term, and that's just a 1. So I know that every P is just going to be over 1 or negative 1. So really, I just have to worry about what the factors are of 15. So it could be positive and negative 1, 3, 5, and 15. And there are quite a few that you would be trying out, and you could try out any of them in any order, and you could plug them in to see if they're a 0, or you could use synthetic division. So if I use 1, I'm going to use synthetic division. So 1, negative 3, negative 13, and 15. We're hoping for a 0 remainder. So if I bring down the 1 and multiply it, we get negative 2. So this is negative 15. So that's negative 15, which means our remainder is 0. So that worked out. So at this point, we know that our polynomial is x minus 1 times the quantity. Since this was our remainder, here's our constant, our x, and our x squared. So this is x squared minus 2x minus 15. We have a quadratic, so we can check to see if it factors, or we can use the quadratic formula to find the remaining zeros. In this case, it does factor, so we have x minus 1 times the quantity x minus 5 times the quantity x plus 3. So that means that our zeros, and we were expecting 3 of them because we have a cubic here, it's a degree 3 polynomial. Our zeros are 1, 5, and negative 3, which means if I had started with any of those numbers in synthetic division, 5 and negative 3 both would have worked. It just would have given us a different polynomial to factor there at the end. So those are our zeros. The multiplicity for each of those zeros is 1 because each factored part shows up one time. And this is our completely factored polynomial. We don't have to factor it any further. We didn't have any complex zeros, so we're done.